Okay, so in this video we're going to introduce polynomials. This is chapter 7. A couple things that we're going to do throughout these videos is we're going to identify, this tells us a little bit about their graph and a general shape. Okay, so the idea is if we can start to identify the type of polynomial it is, we know what the graph is going to look like. We're going to add and subtract polynomials. It's just basically combining like terms. And so this whole identify falls into the second objective, classifying polynomials and describing shapes. Let's look at examples of polynomials. A polynomial, meaning many, right, poly, is monomial. A monomial is a numeral, a variable. So this is an example of a monomial. It's just one thing. Well, polynomial is each one of these guys by itself is a monomial, but when we put them together, it creates a polynomial. And so you'll notice here that this is a line. This guy right here is a quadratic. So we've talked about these specific shapes, but now what we're doing is we're generalizing them and putting them into a larger family of what's called a polynomial. And these guys, line, quadratic, very specific. And then we have a different type of equation here. And so we've already talked about polynomials, but now we're just talking about them as a general sense, not specifically properties of lines, not specifically properties of quadratics, but just what are general properties of polynomials. Here are some examples of things that are not polynomials. And you'll notice here that we have a few things that we've seen before. We have a negative exponent. Well, what does a negative exponent cause us to do? Flip variables in the denominator, variables in the denominator. We have a square root function and we have an exponential function. These guys are all non-examples. So when you see an exponential function, it's not a polynomial. Square root function, not a polynomial. When you see a variable in a fraction, not a polynomial. And these are rational functions, so not a polynomial. So very specific, they need to be in the form of, the y is equal to mx plus b, ax squared plus bx plus c. Those are typical general patterns for polynomials. And we're going to start working with these more specifically, but this is just a basic introduction to what a polynomial is, or what it should look like.